Our second presentation this week continues to focus on text data manipulation. So, generally speaking, we have a variety of library classes that help us to work with a character type of data. There is character. So character holds a single character value and has methods to inspect character data and also make conversions, for example, from lowercase to uppercase and vice versa. String, we've been using a lot of examples with string already, so you have pretty good idea what you can do with a string, but again the highlight here is that it's a fixed string and it's immutable. You cannot change it. If it looks like you're changing your string, you're supposed to get a second copy of it, which is because the initial string is immutable. And if we want to make strings that have changeable data, that we can manipulate the actual data inside the string without creating a new object, typically we use a string builder. String buffer is nearly identical to string builder, but it's the object which normally be used in multi-threaded environment and keeps the changeable string data thread safe on multiple threads. So the character class contains standard methods for testing values of characters, which return a Boolean value. So here we can test, for instance, is it an uppercase or lowercase, or is it a digit or letter or punctuation or white space. So there's a variety of the combination of different tests. All of these methods are static methods inside the character class and return a Boolean true or false to tell you whether it's an uppercase or lowercase and so forth. So strings, these are just summary ideas about the string class. I'm going to fast forward these ideas about the string, and so these are examples of string constructors. Of course, you can always open official Oracle documentation to examine the full list of constructors and methods that are available and read official documentation. Something important to remember when comparing strings: the double equal sign in your if statement will not compare the content of two strings. Rather, it only compares the references, which is equivalent to comparing two memory locations. In most cases, it's probably not what you want, so instead of doing this, there is string equals method that we already used in the past. And so again, just a reminder that remember to use equals instead of double equal sign in your if statement and any other places where you need to compare two strings. There's also due to the popularity of comparisons, there's also equals with an option to ignore case. So both lowercase and uppercase characters will be treated the same as long as they represent the same method. There's also compare to method, which makes strings comparable. So these are highlights of what compare to returns from comparing two strings. And there is also ways to create an empty strings. It's just to highlight the strings can be empty. So empty string, of course, is not a null string. It's an actual object which captures empty string with no characters, and of course the length of such string will be 0. So strings can be empty with 0 length. So, of course, we're using references to strings simply because strings are objects and not primitive data types. So just to highlight here, when we allocate string object like this, right, so this is just allocated string object, and it contains certain characters. So this is a reference to this string. right? So it contains the address of this object, and it knows that this object is a string. And when we duplicate this reference, just like this, just remember that the second reference is not duplicating the object. Obviously, you just get the second reference to the same object in memory. Okay, so the object is not duplicated. It can be pretty long. It can be a very big string that is like, I don't know, megabytes in size. But you can have multiple references to the same string. And having multiple references to the same string makes it possible to use a reference to and pass it as some parameter to a certain method call, right? So we can have an object of some kind, use the dot syntax, and this is the method, and we can pass this as a parameter, and this will be a reference that once again refers to the same string, and we can write some code in this method that gets access through its method parameter to the original string. Okay, so these are the topics important to understand. References to strings, and they're the same idea applies to all objects in Java. Object references are ways that we access these objects. Also, you can construct strings from arrays of characters and arrays of bytes. So here it's possible that we may have loaded some information into an array of characters, for instance, after reading information from a file. And here we're just demonstrating that we have an array of characters, and it contains specific characters like Dallas. And so here we can construct strings from an array of characters by simply passing an array of characters to the constructor of the string, or we can even specify the range of the characters. So here we specify 0 and 3, and it basically tells us that that this is the position where to start, okay, right here. And I believe that the second parameter is actually how many characters we want to extract. So here we want to extract 3 characters. So that would be giving us string DAL. Let's verify it rather quickly. It shouldn't be that difficult to verify. So for instance, we have used some code here. So we have a string. Let's just say that we have string widget right here. So we can perhaps use another string for this demonstration, right? So we can say string. We just how about we just copy all of this and just quickly verify how this works, just to see what happens if we, again, after copying and pasting, it's rather useful to format everything, which brings it to a nice orderly way. And I'll just print system out print. I'll use print line in this output, and I will print string 1 and string 2 like this. Okay, and we can run this code, and you see it prints Dallas and DAL. So the reason that I'm trying to verify it is that if I start with specific character position, right here we have character positions. Character positions begins with 0. Right, so this is 1, this is 2, this is 3, 4, and 5, like this. I'm sorry, 4 and 5. Okay, and so if I wanted to construct this second, I could start with position 2, for instance, and specify that I want 4 characters. Okay, so that would give us this type of string, I believe. Yeah, right. So here we get 4 characters. So this is the amount of characters, and this is the initial position to where to start populating the string. Most of the time you just construct the string from the existing array of characters. So that would be this first choice that we have here. Likewise, remember that right here each character in Java is occupying 2 bytes. Basically, it's a 16-bit unsigned value. It's just like an integer that stores an encoding of a character, but for the purposes of internationalization, it's occupying 16 bytes. But again, when we're reading information from a file, which may be a plain, simple ASCII file, then the characters may be stored there as individual bytes and not like Unicode 2-byte size characters in Java. So in that case, we can construct our city array from a series of bytes, and bytes are of course very small integers that range from -128 to +127, and here we're trying to construct this, and so once again we can perhaps replace the original array of characters with an array of bytes. So right here I just comment this out and construct, replace it with a set of bytes, and you will see that the same thing happens. We get the same exact result from this. So both arrays of characters and array of bytes can be used to construct strings.